All right. And supervised learning process consists of uh, problem definition. Second stage is data preparation. Third stage is develop model. Fourth stage is train and test the model. Fifth stage is assess the performance. Okay, so basically 1, 2, 3, 4, 5 stage are very important for you in artificial intelligence or in AI or in machine learning. So it's mandatory. So the first is problem definition, understanding the problem, which we has three kind of problem here: classification, regression, and tag anomaly. The second is data preparation. Okay, so data preparation basically is data set. Okay, this is data that you're gonna fit to the model, example data, images, text, video, numbers, and so on. And then we're gonna have a model. This is the model that act as a brain. This is the model that gonna analyze all the data set. Okay, so this is a important model here. So in our course, we're gonna learn on neural network. Okay, and the fourth stage is a data set. It's a train and testing the model. So we have a model neural network here. Okay, so we're gonna train and test. First, we're gonna train. We train the model network. We train the model using 80% of the data set. So train means just to make a neural network learn perfectly. So the more data, the more better for neural network to learn. So once 80% are completed, feed to the neural network for training, then we're gonna do some testing. Test means just simply to test our trained model has been okay or not. So 20% of test data input to the model, let the model predict, and we'll see the prediction is right or wrong. So this is a test. So the name is a test. And lastly is the measuring the accuracy. Okay, so the target is 100% accurate. Okay, so accurate means if you make a trend prediction, if you make 10 prediction, all 10s are the right answer. So that is 100% correct, accurate. So if you got 10 prediction, only 5 right, and 5 is making wrong prediction, that means you are 50% accurate. Okay? So after you assess the performance, let's say you got 100% accurate, then you're gonna save the model basically. So this is important, you know. You're gonna save the model. If you don't save it, then the time you spend here is gone. Huh? It's just like your work you don't save in your computer, then it doesn't save. Microsoft Office, Microsoft Word. You after 2 hours you are making an essay, then you suddenly you forgot to save. The computer shut down. So it is a waste. So the same like this. After you have trained the model, the accurate is 100%, which is perfect performance. Then save it. Save it. Okay. Save the model because the model has been trained very accurate. Save it. When you save it, the model is perfect now. And then you save it somewhere. Then you can use it anytime. When you save it, then you can go for deployment. Deployment basically simply just the software goes to the user. The user use your software to do other tasks. The software apply to the car for the driverless car, and so on. Okay, so this is example of deployment. Okay, deployment. So basically, in Iris Flower, you're gonna input. Okay, so this is the input. So you can drag here, you can drag here, or here just to look the sepal length. then you put the sepal width, then the petal length and petal width. When you enter this one, then you press here, then you're gonna come out what kind of flower is there. You're gonna put a picture there, okay? Or okay, so you can predict there. So these are the deployment, okay? All right, and so we're gonna move one by one here. Problem definition, data preparation, develop model, train and assess the performance. First, we're gonna look at the problem definition, okay? Problem definition. All right, so this is the important part, okay? You have to make sure your problem is very clear what to do, what problem you're going to solve. You know, there are safe what things. Problem statement is very important. I do find your final year project, you doesn't cover this sufficiently. Problem statement. You don't know what project you are develop. You just assume this and that, this and then, this and then. Okay, so problem definition is very important. You have to 100% understood and clear what are you trying to solve, what problem you are trying to solve. And if you solve it, it benefit for what, reduce what, and so on. What input, what output. Okay, so in this case, your problem statement can be 3 categories. Okay? The first one is classification, the second is regression, and the third is anomaly detection. So classification basically predict category. Here mean category, remember? Between cat and dog, between iris flower or not iris flower, between car and lorry. You can have 2 category, car and lorry, or you can have 3, car, lorry, and bicycle, or you can have 10, vehicle, car, lorry, vehicle, bus, truck, and so on. Okay, until 10 category. So the word here is category. Predict also can be used as classify. Classify mean you grouping things into category. So remember, this is category. Regression, which is predict, now become predict quantity. Not category. You got 3 category: car, truck, and lorry. But quantity is between what mark I'm going to get on my exam. So the mark be 0 mark to 100 mark. So you got the range from 0 to 100. You can have 0 mark, 10 mark, 15 mark, 20 mark, 30 mark, 35 marks, 40 marks, 60 marks, 61 marks, 62, 70, 80, 89, you can have that marks, or 100 marks. So that's regression, all right, which is more linear a little bit. And category is just simply how many category. You got 3 category, 2 category, and so on, okay? So the last one, anomaly detection, basically is, anomaly is something weird. You're going to detect something weird, something not normal, something happen unusual way. So we're going to detect that. We're going to detect that unusual way. We're going to detect the abnormal thing. We're going to detect weird thing on anything. Okay? In car movement in the highway, what is the weird thing happen? Anomaly, unusual way. So you're going to detect that. You're going to detect the behavior of people, crowd. What are the anomaly behavior, unusual behavior? People lying on floor. So that's considered anomaly. So people lying on the floor, that's mean anomaly, unusual way. All right. So here example is predict anomaly in withdrawal from someone has never been withdrawal the whole money at once. So when it happens, it is considered anomalies. Okay. All right. You have to make sure what's problem you're gonna solve here. Okay. Find it. Either your project is classification group, or your project is regression, or your project is anomaly detection. And look at the category, also look at the quantity, look at the anomaly happen over there. Okay, so that's are three kind of problem project you can have: classification, regression, and anomaly detection. Okay, let's say I'm going to predict a clothing. I'm going to predict the clothing. Okay, clothes. In that case, all right, I'm going to choose classification, I'm going to choose regression, I'm going to choose anomaly detection. The project is about recognizing the clothes, recognizing the t-shirt. When I take a picture of somebody, he can recognize he's wearing a t-shirt. That is a blouse, that is a trouser, that is a, and so on. They can predict what kind of clothing. So that is considered classification. And that thing, how many category do I need for this clothing recognition? 3 type of clothing, 5, 6, and which is 6, what are they? T-shirt, trousers, blouse, or I'm going to classify t-shirt on clothing only t-shirt. We got a t-shirt type A, t-shirt type B, t-shirt type C, t-shirt type D, and so on. All right. So the word clothing recognition, you can have many things. Are you gonna classify all type of clothes? T-shirt, blouse, trousers, jumpers, shoes. I got 5 there. Or you want to class clothing recognition only on t-shirt. T-shirt A, t-shirt type B, t-shirt type C, t-shirt type D, and so on. Okay. So that's you need to clear the problem statement you're gonna have. Okay. Okay. Now look at this one, basically the same thing. Okay, problem definition. Your product is to predict the iris flower. The first thing you're gonna see is the content of the content. So what are the content you want to predict or you want to recognize on iris flower? And we decide it is an image classification. Okay, this predict the iris flower, basically we choose as a classification. Okay, that's fine. So for the iris flower prediction, we're going to choose a classification. And what to classify? I'm going to classify 3 type of flower, 3 category: Setosa, Virginia, and another one. Okay, A, B, and C. So these are 3 type of iris flower. A is Setosa, Virginia. I can't remember what is the third one. Okay, now you clear. You got 3 type of flower, 3 type of iris flower. Iris flower type A, iris flower type B, iris flower type C. All right, look at this. If you just simply look at the single flower like this is only single flower. All right. So you can have iris or not iris. Whether this flower is iris or this is not the iris. There is one. There are 2 label, 2 category, 2 classification. Okay. Iris or not iris. This is iris flower. Other than this, not important. Don't care. All right. So this is a single flower. Only you want to know whether it is iris or not iris. Okay. So another one is you're gonna have 3 category of iris flower: iris, setosa, and virginica. So this is iris. This is setosa. This is virginica. You're gonna you're gonna have 3 label, 3 class, 3 category of flower. So my recognition will gonna predict this is an iris flower, this is a setosa, and this is a virginica. So you got 3 category. Oh, this is iris. Other than this, not important because my software is want to recognize only the iris. On number 3, you have 2 classes. My software can predict either it is a yellow setosa or the purple setosa. Okay, so this is 2 label, 2 object. One object with 2 names. One is yellow setosa, one is setosa but it is purple in color. See, you got 2 label, 3 label, and this is 2 label. So you got 2 label, iris, not iris. You got 2 label, yellow setosa or purple setosa. You see the pattern here? So, and again, problem elimination is very important. Okay, and this is yellow setosa, and this is purple setosa. Okay, so you only predict these 2. Any flower that has yellow setosa, that's we want to recognize. Any iris flower that is purple setosa, that is want to recognize. And here, any flower that iris, either iris, if not it is probably setosa, if not it is virginica. Other than that, not important. Okay, so here you can also set one I think you can also have one classes, one label. Forget about this because other than this is not important. Other than this is not important. 0 or 1. Okay, okay, that's the thing. Okay, now this is the content of single flower. What about the whole tree? Just now is single flower. About the whole tree, this is the tree of the whole tree. Are these 3 are iris tree type of flower or not? So this is a iris tree. This is a flower of setosa, and in terms of the whole thing, tree. And this is the virginica. Okay, virginica iris, the whole tree. You see the difference? And this is yellow setosa tree, and this is a purple setosa tree. Not single anymore. So this is single. This is the whole tree. So these 2 different things, you know. This is 2 different problem statement. You have to clear on this. Okay, you have to clear on this. It's very important you clear this concept, because this one gonna affect your assignment. Okay, we'll see later soon, very soon. Okay, now you will see here. I repeat back again. The contact of your thing. If you consider your problem, consider only a picture of the single flower with the label iris or not iris, it will be like this. If you consider the whole tree, so this is the label still the same, iris and not iris, but now no single flower, it's the whole tree. So these are 2 different category. All right, there are 2 different category. The same is this. We got 3 label, 3 classified. Iris, setosa, and virginica. So this is iris, this is setosa, and this is virginica. And it is a single flower. We want to recognize only the whole picture of the flower, single one. Nice like this. So the whole flower are on the picture. We don't care about the tree, the leaf, and so on. We just only consider the whole flower. single one in the whole photo. You can having the same iris, setosa, virginica, but for the whole tree. So this is virginica, this is setosa, this is iris. Okay. So you got one title, predict the iris flower, recognize iris flower recognition, but you can have two type of problem statement. Now is one single flower, another one is full tree. If we ask the system, what kind of flower is this? So your photo input is just like this. They can predict it is iris flower. You can input to the system the whole tree like this. What type of flower is this? The system also can say this is the iris flower. Okay. All right. So that's the thing. So this is the problem mission you want to need to look is the content contact. This is important, you know. Remember this. Make sure this concept you fully understood. Okay. If you not understood this one, it's very difficult for you to machine learning. All right. Especially the word learning later on. Okay. And next, data preparation. The second is data preparation. We're going to predict the iris flower. Now we are what data set to be collected. What data set to be collected. After you clear your problem statement earlier, this one, you have to ask yourself what data set to be collected. Now, looking at this, our problem statement is single flower. Single flower means our software recognition, the input will be like this only. The whole flower in the photo. No branch, no leaf, no whatever. Only a single flower of input. We want to have the input is just a single like this and predict what flower is this. So the label will be 2, iris or not iris. Now the dataset collection is supposed to be like this. Okay. We have 10,000 like this. 10,000 of the single flower on the whole photo. The whole photo only a single flower. But it can be many angle of your camera. It can be many color and many structure, all those things, you know. Because you can take a picture of single flower from many angle. Top, bottom, left, 90 degree, 60 degree. The lighting could be very good. Another one is not so good, you know. So you can have the fully whole, or you can take from the side. All those things. So your dataset gonna be like this. Because this dataset supposed to be data that the model gonna learn. If you put a single flower like this, you put all datasets not necessary. They're gonna learn something different. Okay. And okay, this one, you got 3 like this. You got 3 classes. So this is the iris flower, this is setosa, and this is virginica. You got 3 label. So data collection is supposed to be first one. So this is for the iris classification, iris label. So you're gonna have virginica label, setosa. Okay, and you have to be virginica. Okay, you got it. So this is one class for iris flower. So you have to collect 10,000 images. So the important is the data that you collect, because this data collect must be reflect of the problem statement of the single flower of iris. So you're going to have all our iris here. You can take this thing and put it there. The same thing. Okay. So this can be this. Okay. Then for the setosa, you're going to have collected another 10,000 images of setosa from many angles, many sides, top, bottom, down, lightening different, you know. And one is big, the age of the flower, 2 years old, 2 days, 3 days, the old one, you know, all of type of single flower to be the image, because we want to learn only single and every sort of setosa. And the third is Virginica. Okay, so you can have like this 10,000. All right, so you're going to have 30,000 then here. All right, I hope you capture this concept. Okay. All right, now that collect data set is important. You know what data to collect. You not just simply, as long as it's iris flower, you just collect it. You cannot like that. You have to think, is this data set important for the model to learn on iris flower? In this case, you got iris and not iris. Are these data set are important for 3 classes here, 3 label here? So you can see the picture, all are flower, single flower on the whole photo. See, you don't see the tree, you don't see leaf, you don't see branch and so on. You don't see iris field of land, only single flower with different orientation, angle and so on. Okay. And if this is another set, iris setosa and purple setosa. So data collection, what is it? Okay. This is a tree of software. It is flower, but now you have to, what are the data collection supposed to be? Okay, so this one, I'll leave it to you. You can guess and let me know. Okay. Okay. So let you settle this one. Guess what the answer and let me know. Okay. You can let me know if it is the right answer. That means your concept is right. Okay. And okay, next. Still collect data set. Now you see the whole tree. The contact is now the whole tree. So the whole tree. No more single flower, but the whole tree. You still have the same label, iris or not iris, but now the data collection is different. Okay, all about tree, branch, leaf. There are so many iris flower in there. So all about tanner image. Okay, and you got 3 label, the same thing, iris flower recognition, but now you got iris, setosa, and Virginia. So you got 3 classes here. Okay. So basically, the dataset collection of these 3 classes, the same like earlier. We got the of this first plus, okay. We got second class, and you got third class, third category, which is Virginia. So this is setosa, this is iris. And you see all the 3. Okay. If you put picture bicycle here, it doesn't mean anything. We want to recognize iris flower, not bicycle. You can put bicycle if you want, but it's useless. Okay. You can put the durian tree here, but bunga durian. You can put, but it's not serve the purpose. It's wrong because it is an iris flower, not just any flower. Okay. Now, if we have a color, consider yellow setosa and purple setosa, and what is data collection? And again, I leave it to you and give me the answer. You can send WhatsApp to me or anything you like. Okay. All right. And okay, now tutorial. So on collect dataset, we have like this. The whole tree label is not label. So what is the question? Okay, we got like this. This is the problem statement, the whole tree. And we have a label, iris flower or not iris. And this is data collection. Question, given query below, discuss the result of prediction by the model. If you put this as an input to this data set, what are the answer? What are the prediction of this one? Are this iris or not iris? Okay, here you have to see the data set collection. This picture are definitely a bit far away from this picture, So it is more white and it is less white. More black, it's less black. And if you put this, I think the software not gonna predict this is not iris probably. Or probably he gonna say this is iris, but the confidence is only 20% it is iris. Because you have this. Okay. And if you put this as a query, definitely you're not gonna say this is not iris. Okay. Because the computer see the whole thing, the whole structure of the tree. He didn't see the small this. It's too detailed. Okay. This model analyze the whole thing, not just simply. So when the query like this, they're gonna say this is not iris. Because he learned something different, they have a query a bit different. Okay. All right. So if you want to predict both right, you have to put both data set, single and whole tree in one data set. So this is important here. Okay. Data set. This concept is very important. Okay. Now we move to another one. Also important is the choice of features. Data preparation. So still the same. Iris flower recognition. And now we're moving to the feature. So it's still the same image photo, but you can have this data set. So here is features of this one. Okay. It's still image, but the features is 4. 1, 2, 3, 4. You can have the same photo, but now the feature is sepal length, sepal width, petal length, petal width. Only 4. And if you have 5.1 centimeter and you got sepal width is 1.5 centimeter, if you got petal length is 1.4 centimeter, petal width 0.2, we're going to predict that this is iris setosa. And you got 1,000 of like this, 10,000 of numbers. So this is numbers. This is numbers. Okay? And text, okay? Numbers. Or you can have like this. This is another features. Features number 1, features number 2, and features number 3. You can have other features like this. So this is a pixel. Pixel number 1, pixel number 2. This is label. Okay? Label. Label 1, 2, 3. Oh, so 7. So mean that your label is, this is the number of image. You got 7 image here. Image number 1, image number 2, image number 3, image number 4, image number 5, image number 6, and image number 7. And from here you got 0, 1, 2, 3. 0, 1, 2, 3. So mean it is 4 category. 4 label. Label 0, label 1, label 2, and label 3. And this is pixel number 1, pixel number 2, pixel number 3, pixel number 4, and so on. And pixel number n. mn. Remember mn last time? So pixel mn, right? All right. So you have 3 kind of things. All right. You have a choice of 3 features to represent the flowers. So this is the characteristic of, this is the features of the same flower, this is the features of the same flower, and this is the features of the same flower. Okay, so you got choice of 3. Which one to choose, up to you. All right, you can experiment one by one. First I'm going to use this, second I'm going to use this, and third I'm going to use this of the same thing. So which one is more accurate? You can do like that. All right. Okay, pixel or energy, or else pixel, you can have a pixel like this. You can have a pixel, you can have energy, contrast, homogeneity, and correlation like this, or else, or you have some sepal length, sepal width, petal length, and petal width. Okay, your choice. Okay, and so you're gonna have predict the size. Okay, the size of the data set. So basically, the bigger is better. The size is bigger, the better, because you're gonna learn more. Right? You're gonna learn more. Because we humans see things from many angles. If I see a car from the back, I know it is a car. If I see a glimpse of a car from the side, I know there is a car. If I see from the top, high-rise building, I look down and I see the roof of the car, I know that is a car. Because in my day life, I've seen car everywhere almost in my life. Left, top, down, front, some many angle, colors, not even colors. I also have learned about the brand of the car. So by glance, I know this is Mercedes, this is BMW, this is okay. But if you put overseas car, probably I don't know. What is this car? I don't know. Never seen before. Because you never see that car. So you're not going to learn anything. So the more features is the better. That's the general rule. If you put one images, there's nothing to learn. I give you one photo that you have never seen before. Just one photo, and I call it one name. So it's not much learn. Okay. So you have 110,000. And from previous slide, we have 1 million, 14 million images collected. That's a very huge image, And it take years, I think, for million images. And so I have 1, 2, 3, 4, 5, 6 images here. And one of the data set. All right. So this is, I guess, 3 classes: iris, vesticola, and setosa. This is another. So this is got iris, setosa. This is only one flower, iris, either iris, setosa or not. And this is all the 3, and this is color. Find me the blue, find me the purple setosa. So they're gonna use this data set. Yeah. So this is one classes basically. All are setosa. You got blue setosa, yellow setosa, white setosa, and purple setosa. You can have a single flower, the whole thing, the contact is a single flower, the contact also the whole tree. So we learn. In this case, you need a huge amount of data. Because for purple, you need 10,000. For this, you need 10,000. For yellow, you need 10,000. For this, you need 10,000 or 20,000. So you can learn a lot. This type of pattern. And what about this pattern? This has color and this is not color, so it's different thing he can learn. You see? So that's the size is bigger, the better. That's the thing that I want you to know. Alright? Alright, I think we have covered up the most important thing, data preparation and problem statement. Okay. Let me go forward. Because I recorded this. I need to finish this, the recorded one. So the third one is we're gonna develop the model. So here we're gonna use a neural network model. There are so many models I have shown you earlier on my earlier slide, but in our course we're gonna particularly look on neural network, right? We're gonna particularly look on neural network. So what is a neural network? We're gonna learn it next week. So basically, neural network basically has the input number 1, input number 2, input number 3, input number 3. So consider this is a feature, right? Consider this a feature. And you got nodes here. Node 1, node 2, node 3, 4, 5, 6, 7. And you got output here. It is a TOSA or not. Okay. So when something inserted to the neural network, they're gonna learn pattern something. So that's why they said. So neural basically coming from the word neuron, brain neuron. So this is brain neuron. 1, 2, 3, 4, 5. We got 5 brain neuron. In our brain, we have billion of neuron in our head connecting to each other. So when someone hit you on your stomach, they're gonna when you put your hand to the hot water, all right. So the cell on your finger will be sent to the brain, and the brain take that sense and conclude hot and what reaction to do and so on. So we got billion of neuron in your brain to let people thinking, experience, knowledgeable, and so on. Okay. So we emitted that. It's a neuron. And network is just simply you got a bunch of neuron here and they connect to each other, become a big network. So we're gonna learn this later. Don't worry about this. But the concept all are the same. So this is a regression. This is K nearest neighbor, support vector machine, K mean. So these are the other. So this is the other model you can learn. I think for the second half you're gonna learn K nearest, SVM probably. But the thing is, when you learn deep learning later on next week, the concept is still the same, but the approach will be different. When we use deep learning, mean that we use this. The layer can be a million layer. Layer 1, layer 2, layer 3, layer 4, until I don't know how many layer. And in each layer, how many nodes you got? This is 1, 2. You can have 1 million nodes here. 1 million. Layer 1, we have 1 million node. Layer 2, we have 1 million node. We have layer 3, 1 million node. At the end of the day, how many million you got? It's a very big neural network. Alright? And the output, you can have 1,000 output. Car, lorry, and so on. So that's very deep. The network is very deep. The analysis of the photo is very deep. The learning is very deep. That's mean deep learning here. Alright? Because how deep it is, because you can have 1,000 label here. Car, house, building, 1,000. And you have here layer 1, layer 2, I don't know how many layers are there. 1 million layers probably. And each layer can be a million or million nodes. You don't know. So that's very deep, very big, huge. And training and testing basically are a bit straightforward. Okay. If you got 10,000 images, you can have trained the model 10,000 images and you can test 1,000 in case of this. So you need all 11,000. So 1000 bagi 10,000 kali 100 berapa? Kita tak boleh. Berapa persen tu? I think sikit sangat ni. The rule is 80-20, isn't it? So 1000 bagi 10,000. 10%, okay. So this is 80%. This is 10%. So you're going to have a total image dataset to be collect is 11,000. When you have collect 11,000, then you use 10% for the training, and 1,000 for the testing. So altogether you have 11,000. Okay. So during your testing, during your test and your train, when you're training your model on 10,000 or you testing your model on 100 images, you can measure your train and your testing, your training and testing. You can measure both of this using this performance. How accurate are the model do the predict? So how accurate are the model going to predict in terms of confusion metric? What is the precision of prediction, recall of, and so on. You can refer this to the book. You know, the book is taught in detail. All right. My book is taught in detail. And okay then. Thank you.